We're in the eastern Grand Canyon at Lipan Point, and behind me is a beautiful view of the unconformity between the tilted uncarved group below, which is part of the Grand Canyon supergroup, versus Cambrian sandstone flat-lying above. And so it's a beautiful angular unconformity. And so there are various units below the unconformity. There's red sandstones and siltstones. There's a dark layer that's basalt flows. And then there's another layer that has ledges and slopes. All of that stuff's tilted. And then there's a flat-lying ledge wrapping around the topography of the Cambrian to peat sandstone. And so the contact between those two rocks is the great unconformity, at least one manifestation of it in here. The rocks below are 1.2 billion, the rocks above are 550 million, and so there's more than 500 million years of geologic history not represented at this place. Now it turns out that a little up canyon, you can see there's some gray slope forming rocks on the right edge, and that's another group within the Grand Canyon supergroup. It's called the Chuar group, and it's a bunch of mostly slope forming rocks, and definitely gray colored as opposed to all these reds in here. And that rock is even younger than the uncarved group. So there's a little less time represented there along that great unconformity, but still quite a bit. When people look at the Grand Canyon, you often say, how did it form? And how it formed is at the bottom of the scene, you can see the Colorado River. The Colorado River is what carved this Grand Canyon. And it carved downward, and then the tributaries went sideways and widened the canyon, and then big rock falls and pieces, just coming off the cliffs helped widen the canyon. And so in here the canyon's fairly wide, and in the lower part of the canyon, you can see it's kind of gentle and slope forming around the canyon, right around the river, as opposed to once you go into the crystalline rocks and it's a steep gorge. And so the people who do boat trips on the Grand Canyon call this Furnace Flats, because you can see there's no trees and it's low and it's hot, there's no shade, and so it's a pretty hot place to be. And it's basically just carved in and among the uncarved group, this middle part of the uncarved group. There are quite a few Native American ruins down in the canyon where they had granaries and things like that. And so that's another thing that people typically visit as they go along the river. Another question that comes up about the Grand Canyon is, how old is it? And it's another one of those things that for a long time people thought we knew the age of the Grand Canyon. And so people said, well, the Grand Canyon is less than 10 million or less than 6 million, and that's the end of the story. And so there was a broad consensus, everybody thought that, and then there was some new techniques that were developed that help you get at the uplift age of the rocks and how close the rocks were to the surface. And so people came in and started doing those types of studies, and one group thought that basically the data suggested that the Grand Canyon was actually quite old, maybe like 50 million years old. Now, it's not like there's a date that tells you it's 50. There was some modeling involved and things like that. And so, it's a little more squishy about what we know because it involves models. But it highlighted that maybe there was a possibility in here that some part of the canyon was a little older. Way down canyon, by Peach Springs, there was really nice geologic work that had been done a long time ago, 30, 40 years ago. It demonstrated that there were canyons that had been cut by rivers flowing opposite to the Grand Canyon, and that they had cut down to some lower level of the Paleozoic rock. So some amount of the canyon in there was actually carved before the rocks that filled those little canyons were deposited. And those rocks are 30, 40, 50 million years old. And so the idea is that some of that material, some of that canyon cutting happened quite a while ago. More recently, people came in and did some of these other new techniques and looked in here, and they said, well, we don't think it's as old as 50 in here, but we think this part of the canyon in here might have been carved at 15 to 20 million. And carved by either, not by the Colorado River, but maybe by the Little Colorado River or some other drainage that's flowing this way. And so there's a lot of evidence in here that the canyon has a complicated history, that it wasn't all carved at the same time. So today I think most geologists agree that there's a multi-stage history of the Grand Canyon, and it was carved at different parts were carved at different times, but a lot of the recent canyon cutting is still less than 6 million years old. And so, you know, when you look at this, you have to realize how much material was removed here in the past 6 million years. And you might say, where'd that material go? The Colorado River goes down along the California-Arizona border, flows into Mexico and goes into the Gulf of California. And there's a huge thickness of sediments down there in the Gulf that's probably the material that came out of here. And at times, the river actually flowed into what's called the Imperial Valley, where the Salton Sea is. And there's a big thickness of sediment in there that's also clearly derived from up here. And so there's a lot of material here, and it got carried down canyon by the Colorado River at various times. And the river wasn't always this little. At times it was probably bigger when there was more rainfall, etc., melting glaciers, all that. And so you had a lot of erosion in here, and then you widen the canyon, and you eventually produce this grand spectacle that we see here. One of the other things that you can see from here is this is the North Rim. For starters, the North Rim is about 1,000 feet higher in elevation than the South Rim, where we are. And so those rocks have a gentle slope, gentle dip towards us in here. There's that, but then you can see in the far distance, the rocks look like they're tilted like that. And the cliff on the far right, which you probably can't see, is called the Palisades of the Desert. And that's also capped by Kaibab limestone. We're on Kaibab, that's Kaibab, that's Kaibab, but they're very different elevations. Between those two, there is a big monocline, a big fold that starts out flat, has a dip, one dip, monocline, and flattens out again. And this is called the East Kaibab monocline. And so it is this thing that uplifted the main part of Grand Canyon that makes Grand Canyon pretty deep, like a mile deep. Because once you cross the East Kaibab monocline, you're in Marble Canyon, and it's half the depth, something like that. And the difference between those is the amount of uplifting and down dropping along the East Kaibab monocline. On the backside of the Palisades of the Desert is the Painted Desert. And so you have the Mesozoic rocks, the Moenkopi and the Chinle, from here east for quite a ways, actually, nearly all the way to New Mexico. And so these rocks were down dropped like this, and so you preserve higher units in that down dropped block, whereas in this uplifted block, you stripped all those Mesozoic units off the top. And so you're now just left with the Kaibab at different elevations. One of the other things that people notice about the Grand Canyon is that the river is much closer to the South Rim than to the North Rim. And most of that is related to the dip of the rocks. So we're down here, so we're lower in elevation than up there. We get less rainfall, less precipitation, and so this cliff is probably eroding back a little slower than the cliffs up there. The other thing is up there you're like this, and the rocks are tilted a little bit towards us, and you're trying to peel stuff off, and it's a little easier to do that than to have this big cliff and you're trying to erode it back. So there's more precipitation. The dip of the rocks is involved a little bit, and then the river probably, because of the dip of the rocks, has probably migrated this way with time. But at some point it gets locked into its position and it's not moving anywhere. So right now that canyon's, you know, maybe in another 5 million years it'll move a little bit more this way, but it's kind of stuck at this point. Another part of the Grand Canyon story that has a lot of discussion going on now is, how do you cut a canyon this big? Do you start with a river that's way out west and it cuts through some cliffs and it keeps cutting and cutting and cutting and come up here, and so you get this thing? Or did you have some kind of earlier canyons here, and then the Colorado kind of finds its way into this earlier canyon and then starts cutting like crazy. There's a third option. East of here, in what's now the Painted Desert in the valley of the Little Colorado River, there are a series of lake beds that are about 8 million years old. And those lake beds accumulate up to a particular elevation, and that elevation is pretty close to being able to pour over some low spot in this wall of the canyon and pour into the Grand Canyon. So you could have had a lake that emptied into the Grand Canyon, and that either really started cutting the modern phase of canyon cutting in the Grand Canyon, or it accelerated what canyon cutting had been going on.